Right, I'm going to make a short clip about the difference between scalar and vector quantities, because no matter how many times I go over it, people always forget. So, very, very quickly. Okay, so a scalar quantity is a quantity that has only a size. I'm actually going to get rid of that full stop there, because a really important word for size in science is magnitude. Okay, it means the same thing. And then down here I'm going to say a vector quantity is one that has both size, magnitude, and a direction. Okay, let's talk about some examples so this makes a bit more sense. So quantities that have only size, let's think. Height. Okay, so I might say 5'10", or I might say 178 centimetres, or whatever it is. I would never say something like 5'10" to the left. Okay, that doesn't really make any sense, so that's a scalar quantity. Other things are very similar, basically any length. So height is a type of length. Mass. Again, I wouldn't say that the cat was 1.5 kilograms downwards. Okay, I would just say the cat is 1.5 kilograms. So again, this is a type of length, but distance. There's a reason I'm putting distance as well as length and height. So height, length, mass, distance. Mine's gone blank now. There's lots of things. Speed. Okay, again, if I'm driving in my car, I'm usually driving about 30 miles per hour, and I don't say 30 miles per hour and then give a direction. I'm just driving at 30 miles per hour. Okay, and then a vector. So some examples of a vector quantity would be displacement. Okay, because it matters how far you have travelled from your starting position. So your direction is important there. Velocity. Okay, very similar to speed, except that velocity is the vector quantity of it. So you would need to give the size, so 30 miles per hour, and you would need to talk about the direction as well. Okay, so is it going left? Is it going right? Up, down, 30 degrees? Where is it going? And another one, really important one, is weight. Okay, your weight, or the weight of any object, is going to act down towards the centre of Earth. Okay, that's a very specific example of the next word I'm going to write, which is force. Okay, so whenever you're talking about forces, you must give the size of it, i.e. the magnitude, so 10 newtons, and the direction. Okay, weight is always downwards, but if we're talking about general forces, it could be in any direction. So I hope that clears up the difference between those two.